Today we were looking at the introduction to physics 112, which is known as practical physics. It runs through first semester and second semester. Now let's start. The first thing here we say practical physics is very essential in the study of physics. Makes physics and valid to the inquiring mind through the result of experimental works in physics. Now, for everyone of us to enjoy very well, are we with me? Are you all with me? Are you all with me?
Have you plugged it? Yes, sir. Is it charging? On the MP.
Okay. I said for us.
Or around all those books that you.
Okay. I said for us to understand our physics very well, we need to understand our practicals. Physics is not just an abstract stuff. It's not an abstract science. It's what every one of us come across with every time. So we are told that in practical physics, physics theories and principles are tested. Students are taught how to set apparatus, obtain data, analyze data, draw a conclusion, and based on results obtained from the data. Now, every one of us will come across the formula, the popular statement, the simple pendulum experiment. We were told that when we swing, we use the simple pendulum to explain the acceleration due to gravity, the value of acceleration due to gravity. And we know that the value of acceleration due to gravity, G, equals to 9.8 times 9.8 meters per second squared. Now, practical physics is very important. It's a very important concept. So it helps us to understand the theoretical concept being taught in our classes. So it's a very important tool to understand the physics of every day. Now, those of us that have not unmute our mics, let us try and unmute the mic. So on the next slide, we have objective of practical physics. Number one, we say training students in scientific method of observation and recording of data. So one of the objectives of practical physics is to train students on how to record to take scientific records and observation. Number two, training students on how to obtain experimental data, handle and assess their values, and develop confidence in one's ability to compute reliable answers or determine valid relations. Now, the next one says train students on how to acquire techniques in handling and adjustment of equipment. Now, for the usefulness of physics practical is to help us to handle some certain equipment. For instance, most of us have not come across the vernier caliper. We don't know what a vernier caliper looks like. We don't know what a micro screw gauge looks like. But when in physics practical, you'll be taught on how to handle these experimental tools. Now, the next one teaches students on how to use specialized equipment. Become familiar with limitations of equipment and errors in measurement. That is another objective of physics practical. Now, the next one, to train students in the use of graphical representation and error analysis. Now, for us to represent graphs, our data in graphs, and or analyze errors, this is another objective of physics practical. It helps us to analyze errors and also represent our data in graphs. Now, the next on our slide here, we have a laboratory directive. How do we do in a lab? Number one, when you are in the lab, the first thing you need to do is you read the instruction for the experiment carefully before coming into the lab. So whatever experiment you are to do, you need to read the instructions of that experiment carefully before entering the lab. Now, the next thing, number two, there says late coming is not allowed, and also absenteeism, it will not be tolerated. Now, this one simply means that when you come late for your practical lab, or when you are absent in your practical lab, it won't be allowed. So you might lose your day of doing practical if you come late for your practical or you are absent. Your absenteeism should be on a condition of when you are not feeling fine. Now, the next one is all breakage or damage to any equipment must be reported immediately. Now, you must be so careful when handling experimental data, experimental tools, so as to avoid breakage or damage unless you are prepared to replace such equipment in the lab. Number 4 says a permanent standard science notebook is required for the reports. Now, this number four statement there simply tells us that your practical lab notebook should be provided for you. Your report book will be provided for you, which you've already bought for doing your practicals. Now, the next slide, materials for physics practical. Materials for physics practical. The first thing there you will need a laboratory manual. The next thing, workbook. The next thing, a notebook for recording values and rough materials. The next thing, you need a ruler. Now, let us take notes. I'm always irritated when student comes to the lab, bringing a short ruler to the lab to do graph. When you are coming to the lab, your ruler should be as long as possible. A minimum length of 30 centimeter or 15 centimeter is allowed in the lab. Now, you need a pencil, your eraser, your sharpener, your razor blade, and most importantly, you need a calculator. Are we following? I guess you are following. Now, the next thing we'll be looking at how we can report an experiment. This is a very important tool when doing experimental works in physics. Now, your reports must be carefully written to show exactly what you have done. That's the first thing. The results and the method of error analysis must be done neatly. Now, the next thing, the report must be neat, orderly, and should be conformed to a definite order. Now, we're showing you how the reports will go while performing your experiment. Now, the first thing for our reports, the first thing for the report is this. First thing, your date. That's the first thing. The date of the report should be written on the top left corner. Then the experiment number. Now, whatever experiment you are given to do that day, you must also write it. The experiment number should be written on the top of the page. For example, if you're asked to perform experiment 1. Now, the next thing, the title of the experiment. This should be written on the first line of the page. Now, when reporting your practical for this level, you'll be asked to share a sheet out of your workbook. Let us take note of that. You'll be asked to tear a sheet out of your workbook. The part that looks like a notebook outline, that's where you report most of your experiments. The first thing, you write your dates. The next thing, you write your experimental number. The next thing, your name, your group number, also very important. Then the title of your experiment should be written all in pen. Write it with biro. Then the aim of the experiment, another important tool. What do you wish to achieve from this experiment? For example, to verify Charles' law or to determine acceleration due to gravity. Let's say, for instance, the title of the experiment is a simple pendulum. Now, the aim of that experiment for simple pendulum is to determine the acceleration due to gravity. We can call that aim, or we can call it what? Objective. Let's take note of that. Now, the next on our slide here, we have graph. That's another important tool, which I will beckon on. Another important tool, which I will beckon on. So the graph, in most experiments, is expected to plot graph. So virtually in all your experiments you be doing is 100 level. You will be that. Each graph should have a title, a very important thing there. Are you with me? Now, the title of the graph, let's say, for instance, we are asked to plot a graph of t squared against m. In this graph, virtually in our secondary schools, we come across a graph of x against y or y against x. But in physics practical, whatever variable you are dealing with, that's what you plot against. Now, for this experiment, for instance, we're asked to plot a graph of t squared against m. Now, the t squared, the unit of t squared, which is our period, is in seconds squared. So this is it should be written when you are writing the title of your graph, against m, which is the mass in kilogram. Are you with me?
Yes.
Okay, let's continue. Now, the axis should be properly labeled with appropriate unit attached. For instance, in our graph, we have, basically in our graph, we know we have y and x axis. Now, but in physics graph, whatever graph you are plotting against, let's say we're having t squared against m, this type of experiment here, t squared against m. Y-axis will be t squared, while the x-axis will be what? M. That is the axis we are labeling, and the label should come with their units, t squared in seconds squared and m in kilogram. It should be properly written on the graph. Another important thing we need to take note when plotting our graph. Now, the next thing is your scale, a very important thing. When choosing your scale, the scale of the graph should contain at least 3/4 of the graph or 2/3 of our graph. Should take note of that. So your scale should be in a way that your graph should be maximized. Your graph should not be as small as anything. Let's say this is our graph here. Our scale, let's say we're having a graph of something like this, our graph sheet. Our scale should have something that should cover up to these points in our graph. Quarter of the graph, our graph sheet. So let me clean that. So the next thing is that all points on the graph are not crowded within a narrow region of the graph. Now, we should take note of another thing when plotting graph. When plotting your graph, You should either use a cross or a star, a small star. You're not drawing big star for it, or a dot. You take a star, a cross, or a dot when plotting our graph. So we should take note of that too. So let's go to our next slide. Now the next thing there, the next thing we're having there is diagram. Diagram. Look at diagram. Diagram. Now, this is not an important concept when recording your 100 level practical. You don't need to draw diagram. But the next thing you need to know that is this. The method you use in reporting your graph, the method you're applying in reporting your graph, you should write it. Yeah, your report, you report how you perform the experiment. That is your method or procedure. It is always written in your graph sheets. But at this level, due to time, you will not be allowed to write the method you use in carrying out your experiment. So this part here, you don't need it while performing your experiment. And also the theory, you don't also need to write the theory while performing your experiment because it's all already written in your workbook, in your graphical work, in your practical workbook. So let's go to the next slide. Are we following? Are we following?
Yes.
Okay, those of us that have not joined via our mic, let us join through the mic. So the next thing we are looking at is recording of observation. Now, the result of all measurements made during the experiment should be recorded in a closed composite table. That means before writing your data out in your 2A sheet, you should draw a table that will either record the time. Your table should have some outline column for measuring the data you collected while performing the experiment. Either the time, the length, the distance, or so. And also, if you are using 2 decimal points, you should be consistent with the number of decimal places you are applying on that table. It should be consistent. If you are using 2 decimal points for the first column, the second column should also have 2 decimal points. Is it clear? So let's go to the next. Now, the next thing is calculation. Now, before calculation, you come to plotting of graph, which we will look in depth because that is the main goal of physics practical, your graph. That's what carries the marks most in physics practical. How you plot your graph, how you report your experiments. Now, the thing where required, you calculate the slope of your graph, record your intercepts, your calculated slope and intercept to calculate the required physical quantity. You also calculate the errors in a determined physical quantity. These I will teach very well how you can calculate your slope from your graph, how you can get your intercept, how you can get your error in intercept, your error in slope, and also your error in any physical quantities, because these are what gives you mark. These are what gives you mark in practical physics. So our next slide, for the next slide, we're having precaution. Now, when performing any experiments, you must always write your precaution before your conclusion. They say state the necessary precaution you took while performing the experiment to ensure accurate results. For instance, your simple pendulum, to avoid to avoid reading To avoid reading wrong, taking wrong reading, you must close the windows, and also put off the fan to avoid air resistance. That is a very vital precaution while taking measurement. And also a popular one we know is avoiding error due to parallax. So we said care was taken, it was ensured. Avoid all personal pronouns. That's what you are asked to do. So when you are recording your precaution, you write, it was ensured or care was taken. That's what you use. Don't use I close all windows, I put off fan. You should use the past tense. It was ensured that the fan was put off before taking so and so, before recording so and so values. It was ensured that the length of the thread was measured properly before taking the first oscillation. That is how you record your precaution in a standard physics practical. Now the next part is conclusion. Now the conclusion part of every experiment in physics is this. Every experiment you are taking in physics, the conclusion part goes like this. The conclusion will either reflect the final results you took while performing the experiments. Are you with me? The conclusion will take the result while performing the experiment. For instance, the experiment to determine the acceleration due to gravity. You can say at the end of the experiment, the acceleration due to gravity was gotten to be 9.2 meters per second squared. The acceleration due to gravity at the end of the experiment was gotten to be 10 meters per second squared, was gotten to be 11 meters per second squared. It tells you that your experimental value that you got already agrees or closely agrees with the existing value that is known to every one of us. Are we following?
Yes.
Okay. So